How to access the Emergency Response Data Platform. Any public safety agency can access life-saving emergency data through the RapidSOS Emergency Response Data Platform. There are two ways of doing so. RapidSOS Portal is a powerful web-based tool that enables you to manage emergencies and access location and supplemental data for every call in your jurisdiction. Signing up for RapidSOS Portal is easy and only takes a few minutes. In addition to emergency management tools and data, RapidSOS Portal includes a training platform as well as administrative tools to manage user permissions, track usage, and analyze trends in your agency. To learn more and sign up for RapidSOS Portal, please visit rapidsosportal.com. RapidSOS also integrates with every major CAD, CPE, mapping, or other public safety softwares. With an integration, you can receive RapidSOS data through your existing workflow, and you won't need any additional screens, tabs, or windows. To learn more about integrations, visit rapidsos.com/public-safety-partners.
All right, let's dive into this section. There's going to be a lot to talk about. We may go the full hour and a half. And if I am, just like I've said before, if I am close, and I don't know, it may be an hour, maybe an hour and 15 minutes, maybe an hour and a half, maybe an hour and 45 minutes. I'm not sure. But I will not stop at 4:30 if I only have a little bit more to go. If I know that I have much more to go, then I will go ahead and wrap up around 4:30, and then I will probably record the rest of it and send it out as an additional recording. But I'll kind of know where we are on time. But it's a lot. It's a lot for this week. So let's buckle up. Officially, welcome to the 2024 On Scene First Summer and Fall EMP Study Group. This is week 12, Next Generation 911 stuff. You know, the stuff we've been hearing about since like, I don't know, 2000. And we're still trying to get there. But we are in the tail end of our live study group. So if you are catching this before June 21st, which is next Friday, and you would like to be added to those last two live sessions, I have one on Wednesday and one on Friday, then go ahead and head on over to onscenefirst.com/training/study EMP, or scan the QR code to the left. And I will be happy to get you added to the Google group. In the Google group is where you can access all of the recordings, all of the additional materials that I have shared, as well as all of the PDFs and any MP3s of the sessions. Some folks like to listen to them, to and from work. I don't know if I'd want to do that. I like to listen to true crime podcasts, but nonetheless, a lot of folks will send me a picture of them listening to me in the car. And if you are joining us after June 21st and you are planning on taking the summer or the fall, or maybe even the early 2025 exam, and you would like access to all of the archived materials, they will all be relevant until they're not. If something needs to be updated, I will add that and make any changes as I get wind of anything that has changed. But it will be a little bit before there's another live study group. So accessing it through the archive stuff will be the way to go after June 21st, 2024. And so if you would like to get access after June 21st, head on over to that same website, onscenefirst.com/training/study EMP. And then if you would like to get notified when I have another live session or to keep up with my shenanigans, just head on over to onscenefirst.com and go ahead and subscribe. I got lots of cool stuff that I do from time to time. So if you want to keep updated on that, head on over. I forgot I moved slides over, and I erroneously forgot to add the RapidSOS slide as our premier study group sponsor. Thank you to RapidSOS. If it wasn't for them, I wouldn't be able to do what I've done over the last 8 study sessions. So thank you to them. And let's jump in. So these first a few slides. They are pieces that I have pulled from other sections, and they are in this section because I feel like they're more pertinent to this section. So I just gave you the title of this section. So if you are following the outline body of knowledge and you're wondering why we didn't go over some things, you might see them here. So this part is these couple of slides are from earlier, like week 2-ish, when we went over principles of telecommunications. So there's just a few things here. First being quality of service. And so you see that abbreviation QoS. The O is lowercase for the of, but the quality of service in general is a set of technologies and practices used in telecommunications and networking to manage network resources and ensure efficient, reliable delivery of services such as voice, video, and data. The QoS is essential for maintaining high performance and user satisfaction, especially in environments with limited bandwidth and varying network conditions. So think of it just like your quality assurance in the 911 center, but it's on a network. So it's constantly checking pathways, it's checking the speed, the integrity, the amount of traffic that is on any one part of the network at any time. The key objectives of QoS are prioritization. So just what it says, prioritizing critical traffic over less critical traffic when it comes to the processing of the 911 call. Bandwidth management, allocating appropriate bandwidth to different types of traffic to prevent congestion and ensure smooth operation. So, unfortunately, we've had scenarios where our 911 systems have been inundated because of big major incidents, and sometimes the calls need to be sent in different directions, going to backup agencies, etc. So quality of service helps with that as well. Latency control. This minimizes delays in the transmission of data. It's crucial for real-time applications like VoIP and video conferencing, so it's not choppy, right? So when we think of next generation 911, we're going to start seeing videos, et cetera, that are coming in addition to our voice. So making sure that those pieces are being delivered clearly is important. Jitter reduction ensures consistent data packet delivery intervals to avoid variations that can affect real-time communication. So if you remember a couple of weeks ago, we talked about packet frame relay or frame relay when it comes to delivering packets of data. And if you remember frame relay, I referred to it as kind of like a relay race, right? So large amounts of data getting from one location to another. So if you think of it as kind of a relay race, you have that, say we have a team and they're the relay team. They are all going to stand at the starting line to begin with, and they're going to kind of space out and they're going to run at different intervals. And then at the end, they're all going to come back together as a team. And that's kind of what is important with the jitter reduction, is to make sure that all those pieces get to the finish line so we don't have pieces of the information that's missing. And same with packet loss minimization. So to reduce the loss of those packets and ensure the integrity and reliability of the transmitted data. The next section is network configurations. And this is where we're going to talk about the grade of service. So the grade of service is a metric used in telecommunications to quantify the quality of service provided by the network. It measures the percentage of service requests blocked or delayed due to network congestion or unavailability. I like to think of this as like the little thing in the road that kind of you drive over when they're trying to, check the traffic patterns. It's kind of like that in my eyes, or a piece of it is anyway. In other words, The GOS assesses how well telecommunication systems can handle incoming service requests without experiencing an overload that leads to blocked or delayed conditions. If you notice with a lot of those things that they put in the road, you go over one and then you go over another. And then there's like a formula or something to kind of how fast did you go over it? Is there any delays? Is there, issues affecting it, etc. How much traffic? And there you go. Blocking probability is closely related to the grade of service, and it's another metric in the telecommunications network. It represents the likelihood that a service request will be blocked or denied due to network congestion or resource limitations. And I got a Tracyism coming up to tell the difference between the two. In other words, it measures how often the users may experience blocked connections when accessing the service. So I'm going to use a toll booth analogy. The grade of service can be considered the highway capacity. So how many lanes do we have? Do we have one lane and we can end up with some congestion at certain times a day? Do we have a 6-lane highway? Do we have, as I mentioned a couple weeks ago, the ability to shift lanes, like the HOV lane moves from one side to another at different times? So if you think of the grade of service as that yellow road there, think of it as the highway's overall capacity. Think of the highway's overall capacity as the grade of service. It's like the total of number of lanes that are available. The higher the GOS, meaning the more lanes, indicates a better chance of your car or the service request finding a clear path without being blocked or delayed. If the highway has a high GOS, it can handle a large amount of traffic without causing any congestion. But then you have blocking capabilities. The toll booths on this highway are going to be what we consider the blocking probability. Picture the toll booths as the point where the service request can be blocked or delayed. This represents the blocking probability. Blocking probability is like the chance that your car will be stopped at the toll booth due to congestion or limited resources. A lower blocking probability means fewer toll booths, causing delays and ensuring a smoother traffic flow. How about that analogy? It took me a while to figure that out, but it makes sense in my brain. And now into the network, E911 network design and architecture. This is where I'm going to start talking another language for some folks, but I will do my best to explain things relatively easy. So I know that I have mentioned before that folks will bring back information regarding something that I didn't go over before or something that they don't recall seeing. And this was one of those things. So I recommend knowing what third generation partnership project is, 3GPP. I remember the first time somebody sent that back and I was like, what's that? I don't remember seeing that anywhere. I've never heard of it. But guess what? It's buried really small in your manual. And I found it, and here you go. So when it comes to mobile communications, the third generation partnership project, when you think of partnership, is a collaborative initiative that unites 7 telecommunications standards development organizations known as organizational partners. The goal of 3GPP is to produce globally acceptable technical specifications and reports for mobile communications. So it's a group of folks that come together and make sure that things are being done in a way that they should be when it comes to mobile communications. Also in this additional section, which we hadn't covered, is some different types of mobile radio, wireless. I might move this if I do another study group or when I archive the materials, I may put this with the wireless stuff. but I think it belongs here also. So CMRS, Commercial Mobile Radio Services. It is also known as your wireless service provider. So AT&T, T-Mobile, Verizon, those. The FCC's term for a carrier or licensee whose wireless network is connected to the public switch telephone network. It is like the overarching network or the super network that powers your mobile phone. It is the behind the scenes technology that allows you to make a call, send a text message, use the data on your mobile phone. So just imagine that super highway up there. There are some legacy CMRSs providers that have deployed a few different types of networks. So there is one is called Code Division Multiple Access, CDMA, and some have provided global systems for mobile communications / universal mobile telecommunications. It is my understanding, and I could be wrong, is that it depends on who your network is as to what benefits you have based on which deploying that it is. So I know that there were like Sprint didn't allow, and I don't know if they do now. I know this was a huge problem when we were trying to roll out the device-based location at Rapid SOS, but they didn't allow voice and data to be delivered at the same time. That's a problem, right? And so I don't know who would buy a phone that you can't be on the phone and scrolling on the internet at the same time, but it is my understanding that these two different types play into that particular role. So CDMA is a unique language system for mobile phones that allows multiple users to talk at the same time without interfering with each other. So imagine in the old days, remember when you had the old party lines, or you had to share a line with someone and you had to jump on, and it was like, oh hey, Sophia, could you bring me over a cup of sugar, but there's like 4 other conversations going on, right? So CDMA makes it so wireless devices have kind of that private communication path. It is a spread spectrum multiple access technique. This technique spreads the bandwidth of the data uniformly for the same transmitted power. I like to think of it as a silent disco. Okay. So as far as the digital conversations go, it is, you put those headphones on. There are unique codes. So the headsets are set so only 2 people can hear the conversation, right? But in the silent disco, your headsets are programmed for you to hear the conversation. It allows for simultaneous talkers. So yes, others have the headphones in the silent disco, but you're only hearing yours. So you're not hearing other people's conversations as well. It's an efficient use of space. It allows for as many people in the room in the silent disco to hear what's going on. So that means multiple calls can be going on. And then there's a clear communication because it's not overcrowded on that same network. The Global Systems for Mobile Communications, GSM, is a 2G technology. We are definitely moving past that. And then UMTS is a 3G technology. Both GSM and UMTS are widely used in Europe and other countries. So here we tend to steer towards CDMA. In addition to our mobile radio stuff, we have what is called small cells. I do recall a question being on one of the cells. I just don't remember which one. But when you think of a small cell, think of that smaller, right? And how much smaller, and with smaller comes some restrictions. So we'll just kind of keep that in mind as we go over these next couple of slides. A small cell is like a mini cell tower that enhances mobile network coverage and capacity in specific areas. It is compact, low-powered wireless communication system that complements larger cell towers, providing improved connectivity in densely populated or high traffic locations. It has a range of 32 feet to a mile. So sometimes these are put up when we can't build a large tower infrastructure to create the much bigger macro cell, which we'll talk about in a minute. And so these smaller cells are just kind of popped up or thrown onto something else to say, hey, we want to just kind of extend the range of this mobile radio signal. Small cells, if you picture a compact Wi-Fi extender or a signal booster strategically placed in the different areas of the building. Now, I know that when we had Nextel, we had to put in one of these extenders to make sure that we could receive the signal in the building that we were in. So a small cell can be kind of compared to that. So small cells are like mini boosters, enhancing cellular coverage. And I just want to be clear on that is the small cell is enhancing cellular coverage in specific locations, such as street corners, stadiums, shopping malls. Visually, you can think of it as a discrete integrated into the environment, contributing to an improved network. A femtocell is a subset of a small cell, and it's also called a microcell. So the small cell versus a macro cell. So you think a small cell being out in the public, in the world, at the stadiums, at the movies, at the stadiums, shopping malls, large facilities, large congested areas. And then the macro cells are, the bigger towers that are strategically placed, rurally, all over the place, etc. But now we're going to go even smaller. And the femtocell, which is also called a microcell, much smaller. It's a subset of the small cell, but getting much smaller. These devices are similar to wireless routers with a typical maximum range of 10 meters. Now, why do we use meters in 911 stuff? I have no idea. They're smaller and usually in houses or businesses. It can connect to the service provider network. Sorry, it connects the service provider network to the broadband network. So what it really does is, so if I have an AT&T phone network, and the AT&T network in my house is shoddy at best, then I can put in a femtocell, which will then take that AT&T signal, turn it into a Wi-Fi signal, and send it out over the interwebs. And then it becomes kind of a VoIP call, or a mobile VoIP call, if you will. Lots of problems with that when it comes to calling 911, because it doesn't always come in the way that traditionally as it should. And then that's where we might get some calls that route to Northern 911 if they're not provisioned correctly, if there's a discrepant address associated. Big mess there at times. Femtocells can only accommodate a few users at a time and are usually deployed indoors. And depending on who you are using, some of them require you to add your phone number to it, meaning only the people in my house are able to use it. But what I can tell you from experience is that it doesn't matter if 911 is being called. If you're calling 911 and there is a femtocell in the home and the signal's not great, it could use that femtocell to call 911. And I'll show you an example of that. The analogy for a femtocell is visualize a small dedicated wireless router that is placed inside the home that just turns your cell coverage into a wireless a Wi-Fi based call and sends that on as if it is a mobile VoIP call. Femtocells are like personalized signal boosters for residents or small offices. They are compact devices designed to enhance cellular coverage within a confined space, providing a localized and reliable connection. And while, yes, it's a reliable connection, it's not always routed appropriately, so they can be challenges. Here is an example. I've mentioned numerous times that if I am teaching something in this class or session and I have a teachable moment or something that I want to share, I'm going to do that. And so that's what I'm doing here. This is a call, this is an alley of some that someone had given me in Louisiana when I was teaching about femtocells, because I have another example I'm going to show you in a sec. And they said, "Oh, I got one of those." And I had no idea what it meant by that. So here is the alley. And just so you know, there might be some identifiable characteristics that come in on the alley. In this case, the word femtocell is there. I want to raise a red flag and go back to the importance of address confirmation as well as wonky addresses, especially when it comes to calls coming in differently. And I have a section in one of my classes that I teach this, so I'm just going to share it with you guys because you never know. It might pop up for you. So in this particular alley, it shows the femtocell. You know that it's a femtocell. So right there, if you see the word femtocell on your alley screen, the hair on the back of your neck should go up. You should be aware. You should make more of a point to make sure that you have adequate address confirmation. And if that caller cannot tell you the address, I just want to point something out. Okay? This is just something learned along the way. So this alley right here, it is giving what we call and what we learned last week, I think it was, the GIS stuff and geocoded and reverse geocoded. This 13231 Oakbourne Ave, that address is a reverse geocoded address. So what they did is they took the latitude and longitude, they turned it into a civic address, and they plopped it on the screen. However, the lie detector determined that's a lie. But the problem is there really isn't a way to know which address is the actual address of the call. And so when we are still talking about some address discrepancies, this is why we like software like the Rapid SOS portal, because that location is coming from the operating system on the device, and you're pretty consistently going to get a valid location. But in this case, I want you to see what happened. So this address right here, 13231 Oakbourne, is right here. 13231 Oakbourne. When I take this latitude and longitude, and remember in GIS world, you saw me use this in that session last week when I talked about the importance of putting your latitude and longitude in a search the correct way. So remember, positive comes first. We like to be positive first before anything. So in this one, I had to take the positive first and put that in, and then the negative and put that in. And so this reverse geocoded address is this house. This latitude and longitude is this house. That's a big bucket of sock. So what happens is if at any time, so if you take it face value, if the caller can't speak and you take it face value, hey, and you dispatch your officers to say an open line domestic, and I hear people yelling and shouting, etc., and the call disconnects, and you send them to 1321 Oakbourne Ave because that's what you're showing on your screen. Just know that it might make sense to check that latitude and longitude as well, because you may have two different locations. Why? Because the femtocell decided to get involved and be a knucklehead. Does that make sense? And so there you go. You can see the two different locations, right? So from here, it's just a couple houses down. From over here, it's a few more houses down. So just be cautioned. Anytime you see anything on the alley that indicates there's some other type of device that has sent this through, be cautious. And I'll tell you about another one in just a sec. The macro cell is a cell used in cellular networks with the function of providing radio coverage to a large area of a mobile network, usually has a range of about 20 miles. A macro cell, imagine a traditional cell tower with antennas and equipment mounted on a tall structure. Explanation: macro cells are large-scale infrastructure of cellular networks. Visually, think of the iconic cell towers that cover a wide outdoor area, providing extensive coverage. So small cells, they're just the little ones that we pop up to enhance that signal, and macro cells are the much bigger ones. Fixed mobile refers to a service allowing users to have a fixed line and mobile communication capabilities within a single device or service plan. It enables seamless communication whether users are at home, fixed, or on the go, mobile, offering flexibility in how they connect with others. So, as we talked about a femtocell could be considered a fixed mobile device because it gives you the option to either be on the network or on the intranet. Okay. Visualize a mobile phone seamlessly transitioning between Wi-Fi and cellular networks within a building, which is what I just described. And fixed mobile represents the convergence of fixed and mobile services. It doesn't have a distinct physical appearance, but symbolizes a unified user experience where services seamlessly shift between fixed lines and mobile networks, ensuring continuity. The thing with these is 1 minute you can be on the network and then you can be on Wi-Fi, then on the network, then on Wi-Fi. And this is an example of that. And again, using a previous call that I use in my training classes for this point, there is something that should immediately tell me something is different, and it's the word fixed. Okay. So here it says fixed ATTMO. So fixed AT&T mobility. That should tell me right off the bat that if there's something wonky with this, it's because they got a little thing in the house that is changing stuff around and it's not coming through traditionally. And this was one of those situations. So a couple of things. Number one, the area code on the call is 911. So that would indicate or could indicate to me that that's a disconnected cell phone, right? It was. But what happened is it is coming through. I should have moved this little arrow over the top arrow because it is a wireless phase 2 call. If this is a wireless phase 2 call, then this address right here should be, in theory, a tower address. So by definition, if there's a wireless phase 2 sitting on my alley, the address that is listed there is wireless, is the tower address. Well, the lie detector determined that's a lie in this situation. 21 Bishop Road is a home. there's no tower there. And so when you look at this, the address on the alley, as well as the map plotting for the wireless phase two and the latitude and longitude are all coming back to the same location, 21 Bishop Road. Now, this ended up not being a major, incident. I did get permission to use this for a particular for training, because what ended up happening is two young knuckleheads decided that they were going to tell the lady in the phone to dial 112. So there's like stuff goes out on the internet that says don't tell the lady in your phone, and I'm not going to say her name cuz she'll do it, or tell the lady in your phone to call 112. Well, that places a 911 call because 112 is the European number for 911 and it is reciprocal here. So when our police went to the house and said, "Hey, we got a 911 call from here," the kids are like, "We didn't call 911." And if they did take a lie detector, they didn't call 911. They called 112. So while we had a disconnected cell phone, a wireless phase two with the address of the home, not the tower, this is what I refer to as a wonky location. So don't always take location at face value. I'm watching a pretty heavy trial right now here in Massachusetts. And let me tell you, there's some things we need to be doing a better job at. And one of them is, looking at the things that are in front of us and not settling and not just checking boxes. So know how to troubleshoot those. So let's move on. The next generation 911 piece. Why next generation 911? Because this is where we're at, right? The evolution of emergency calling technology is beyond our scope and what we needed versus what we need now. It is being driven by advances in our technology. Our phones are saying that we should have better things to go to 911. The technology for the networks is better. Being able to receive additional information, make things faster, redundant, etc. And this is what it looks like. The core pieces of it is we're going to replace Next Gen 911 is replacing the legacy infrastructure with modern infrastructure. We're still using similar systems in the 911 space as we have been for probably the last 15, 20 years. We are on the computer-based phone systems. Most are anyway. I don't know any that are not. And we're still relying on similar information from the callers and their devices. What an expanded view of Next Gen 911 looks like is being able to send additional media type data, with text to 911 being the first, and then getting location data from supplemental sources, which is that additional data, location data from the device versus triangulation and tower location. It is also redundancy. If my system goes down, I should be able to just pick up and go to my neighbor's house and be able to use their system. And then the additional data portals and any type of web applications, which we are seeing in like the Rapid SOS portal, the Prepared Live, etc. These are tools that are allowing next generation pieces to come in. Do we want them all in the same place? Yes. Is that going to happen? Not for a long time, if ever. In our legacy environment, legacy routing will find the caller. So the call will hit the tower. The call will go to the 911 center that's associated with that tower. And then it will send out a request for a more precise location. So the legacy routing is looking for the caller. The next gen routing finds the right PSAP based on the caller's location. So geolocating the caller first and sending it to the right PSAP based on that geographic location. That makes sense. I'm proud to say that I believe, and I could be speaking out of turn, but it's what I was told and what I heard is that Massachusetts was the first full state deployment to use geolocation for their routing. So it's a whole state thing, and it's extremely beneficial because it cuts down on misrouted calls as long as your information is correct in your boundaries and your geofencing, etc. Garbage in, garbage out. Good information in, good information out. This next generation 911 piece is just a snippet. They just want you to know a snippet. If you got bogged down in, like, if you went down a rabbit hole of next generation 911, it would make your head spin. I like the level of knowledge that I have at this point. I don't think I would want to go any further because that it gets a little squirrely. But there's some folks that take this stuff very seriously. I've been in some meetings where people are just like, "Woo!" They lose their minds if things aren't being done the way that they should, or how the NINA standards are requesting them to be, etc. People get crazy. But just know that this section is a snippet. It is just a piece. I'm going to share a couple of resources with you that are important. They are listed in the manual. They want you to go over these, but I'm also going to share. I meant to put a screenshot in of it and I forgot, but I will upload a PDF document that is super simple to read and understand. That is kind of an overview of this entire section. And then I am in the process of finishing creating one that will come from me as well with a little bit of different information. I highly recommend spending time on this week's session. If you are not familiar with this is the piece that you're going to come away going, it was really technical and I didn't know that stuff. As I mentioned in the first week, it may feel like one of your exams is either really heavy on the tech side or it's really heavy on the operational side. It's not heavy on either side. The technology piece is 50%, the operations piece is 50%. What we do know is when you can't answer the questions because it's not your area of expertise, that's what the test feels heavier in. So just know they have 50% and 50%, and those 50% are broken down into other little categories, but spend the time here. Put the time in here. This document, the Next Generation 911 Public Safety Answering Point Requirements, generalized. This goes deep into, tech stuff, but it may have some of the definitions you might need. NINA I3 standard for Next Generation 911. It is also listed there. I3 being the core components of how the technology should be implemented. And then here is just kind of an overview of some of the things that we are going to be going over. So I'm not going to get too far into this. Hold on, just gonna, it's a little warm in my office. It's nice to have warm weather. This is just a quick overview. This is a replica of one of the images that is in your manual that I just kind of recreated just to have here. It's just a little cleaner. But we still have legacy systems. We have IP network systems. But nonetheless, they have to talk to each other. So if there's a PSAP over here that's a legacy PSAP and that call's got to get moved to a I3 next gen PSAP, there has to be changes along the way. There has to be pieces or ways for that to happen over time, over the network. So we'll go through those. Don't worry. Some general terminology: internet protocol networking. I'm sure you've heard the term IP, right? So IP address, etc. But IP, internet protocol, is a method used to transmit data over the internet. It uses transmission control protocol and internet protocol. And there's your acronyms there. The function is to address and send data packets. That's what it is. Where is it going? What's the address? And what is it that we're sending? And is it big enough to go this way, or does it need to go a different way? IP networking is scalable and extensible, which allows for growth and change over time. I mean, I think there's a mindset that at some point I'm going to be able to send a 911 call from Rochester, Mass, all the way over to California through the 911 network. And I should be able to do that, right? But right now, with a fragmented system across the US, we don't have that ESI net that is going to be able to do that yet, until everybody is playing in the same sandbox. And then the IP protocol is the foundation for the ESI net. Now, folks call it the ESI net. I will not call it the ESI net, because they called it that once, and one of the tech people almost made me give them my firstborn. You would have thought that it was that serious. It's not ESI net, it's ESI net. And I was like, okay, but I don't really even know. And so I don't know who's who's the rule maker there, but just know it's tomato to me, but I will call it an ESI net. Just because I still have trauma over that conversation. Not sure why these are out of order, so I'll just throw them up there. IP applications. Yeah. So Claire put, it's funny, in Colorado, everybody calls it an ESI-net. And that's what I called it, because that's what I thought it was. And good Lord, this person was very adamant. I helped build that. And I was like, okay, all right, I'll just call it an ESI-net. I'm thinking there's other battles we can fight, but nonetheless, you do you, boo. IP applications for 911. This allows seamless access to 911 services from many communication services and devices, whether it is fixed. Now, this is a different fixed. So we talked about fixed mobile. This fixed is a device that connects to a single access point and is not capable of being moved by the end user. So that's your traditional landline phone. It could be considered a VoIP type phone that is not the VoIP that you can pick up and take with you, but the network multi-line phone systems enterprises. And then you have mobile, which is capable of being used from more than one location, so our mobile phones. And then nomadic. Nomadic is new to many of us. It is a non-fixed VoIP service, enable the end user to connect a handset or IP-enabled device to multiple access points: Zoom, Skype, WhatsApp, maybe even like Facebook Messenger down the line. These are places where we can have what simulate a phone call or communication. And there are going to be nomadic means for those devices to call 911. Can that be a challenge? Yeah, absolutely. Because if I was doing this presentation, so next Wednesday, I'm going to be sitting in a hotel room doing this presentation. If I'm on my Zoom, that location, if I was to make a 911 call through this phone application or such, it's going to need to know my location of where my account is currently, where the IP address of and the geolocation of the call, etc. IP networks allow PSAPs to receive additional data such as texts, pictures, videos, telematics, floor plans, medical records, subscriber information, CCTV, and sensor data. So this is that additional data that we've been talking about for a long time. ESINet, Emergency Services Internet Protocol Networks, ESINet. A managed IP network that is used for emergency services, communications, and which can be shared by all public safety agencies. Like I said, the goal is to be able to get everybody on an ESI net and that those ESI nets can talk to each other flawlessly. ESI nets provide the IP transport infrastructure upon which independent application platforms and core services can be deployed. So, core services are, hold on, I forgot I have a bullet on that. An ESI net may be interconnected at the local, regional, state, federal, and national level, and international levels at some point, right? And the ESI net is a network of networks. It is not the services that ride on the network. That's your next gen functional elements, etc. Next gen core services, the base set of services needed to process a 911 call on the ESI net. This includes, but is not limited to, some of the things that you see here: the ESRP, the ECRF, LVF, BCF, Bridge, Policy Store, logging services, typical IP services such as DNS, domain name server, and dynamic host configuration protocol. Now, we're going to go over most of those. We're not going over all of them. I have there in capitals. You do need to know your acronyms, because what's going to happen is they're going to ask a question about ECRF, ESRP. They're not going to give you what it is. You need to know what the protocol is. Next gen core services include the services and not the network. But in a lot of cases, if you have a company that provides next gen core services, they're usually providing the ESI net as well. Next generation public safety answering point, it is just that. It's a term that denotes that the PSAP is capable of processing calls and accessing data services as defined in the I3 specification. So the I3, I'm not getting into the I3. Just know that I3 is a whole lot of if this, then that. This is how you do this. This is what you put. This got to have this and this and this and this and this. We're not going in that deep into that. If you want to have fun, but I think generalized, just knowing what an I3 PSAP is good enough. Functional elements. Functional elements are used to define certain elements in the next gen 911 system. Functional elements is a set of software and hardware interfaces and operation to accomplish a task. FEs perform various tasks, including but not limited to conversion from a legacy to next-gen signaling, security, call routing, and call handling. They all have their place. I apologize. I have something in my eye. For databases and applications, FEs may be GIS, additional call data, web or user interface functions, or other generalized location information. So it's bringing in data from all kinds of different places. Stick with me for a minute. I do recall there being a question. I want to say it was on the XML or the like. I'll try to give you a couple of Tracyisms here. But they want you to kind of know what this stuff is. We've heard about it, we've seen it. Um, do we really care about it? Not in everyday life, but it is in the book, and I do recall seeing a question or two on this stuff. So, JSON script. Script can be considered how the information is. So if you go back to remember DOS stuff, right? And code, there's all kinds of um folks will refer to the way things are written out in code. So going back in the computer days, early computer days, if you wanted to do something, it was like you had to make the little greater than, less than, and be like, oh, search this, and it was all like codes and stuff. Yeah, I didn't love it then. I don't like codes like that. I like using my mouse. I like clicking on things and pictures. But we're gonna just talk briefly about the different types of formats in which information can be received and um, delivered. So JSON. I made a little character there because Jason sounds like Jason to me, and Jason's very friendly. He's very easy to get along with, and he's nice. JSON, by definition, is a lightweight data interchange format that is easy for humans to read and to write if they had to. It's also easy for machines to parse and generate. JSON is a common data format that diverse users in web development and data exchange between applications. So it's pretty straightforward, cut and dry. But I think once we get into more higher standard stuff, it needs to be a little more complicated. But nonetheless, if it's asking the question, I don't know what's in my eye. If the question is related to something being easier to understand, um, easy to do, etc., we're going to remember Jason. Jason's easy to get along with. He's a nice guy. You know, he's looking pretty fly in his little outfit there. So pretty easy to remember. EIDO. I know this is on there, and I'm going to do my best to explain it. EIDO is a JSON based, also JavaScript, because JavaScript is like this, and then JSON's underneath it or within it. You don't have to go that deep on that stuff, but EIDO, you're going to kind of need to know what it is. And I don't know why, but every time I see it, I'm like, EIDO. I don't know why. I just do. It just EIDO. Emergency Incident Data Object. The EIDO and its conveyance mechanisms replace the serial port data connection between the CPE and the CAD and provide a standardized CAD to CAD interface. Now, I'm going to assume it was using EIDO when I was able to go into my CAD and see our neighbor jurisdictions incidents, or if I needed to look up somebody in their CAD system, there is a standardized format through the internet, through a secured internet, that allows me to be able to bring in and see that information. It's creating a format that allows us to have other pieces of the network working in tandem with our network. It provides a standardized way to send incident data to emergency operation centers, tow truck operators, utilities, news organizations, and it's based on the EIDO standard. It's how that information is being sent over, what format. I'm going to go back to the NIEM that we talked about last week, where everything's going to be kind of in a specific format. So EIDO can be considered like NIEM. And it's basically a snapshot in time that goes from one place to another. And this is what EIDO could look like. And again, so it's a JSON script, right? And it's basically taking this information, moving it over somewhere else, and making it possible for them to be able to read it on the other side. I do feel like this is the one that I had the question on. I don't remember fully what the question was, but I just remember XML. Um, XML is a simple text-based format represented structure information, documents, data, configurations, books, transactions, invoices. It's a file format for storing, transmitting, and reconstructing arbitrary data. Again, I don't remember exactly what the question might have been, but there you go. And then JavaScript, this is how I'm going to remember Java. So again, if you notice, they're all very similar, right? Like, so JSON looks similar to XML, looks similar to Java, and it's going to look similar to Pitaflow, which is the emergency communications type this. But the JavaScript, the reason why I have the coffee up there is look at the words. A program language that is one of the core technologies of the World Wide Web, just like coffee is one of the core things in an I1 center. Java is a high level object oriented programming language used to develop a wide range of applications, from web to mobile applications to enterprise level. Much more complicated, and I need my coffee to be able to to dig in and understand this. Without coffee, we're not understanding it. So there's Java. Java has strict syntax. Syntax is that the way that things are worded, the placement of every period and plus sign and spaces and all that stuff. Very strict, very strict. And it's used for building complex, large scale applications, including desktop applications, web servers, and Android mobile. All right. Structured Query Language, SQL. SQL is a domain specific language used for managing and manipulating relational databases. It is designed for querying, updating, and managing databases, allowing users to interact with databases, to retrieve, insert, update, and delete data. And it is fundamental in database management systems. I look at the SQL like the librarian of databases. That librarian knows where every book is. It knows if we have the book. It knows where the book belongs, etc. What I will tell you is that what I would recommend, let me say that. What I would recommend is you don't have to know every piece of what SQL does. Find a way to generalize remembering it. So to me, I would be like, SQL, I'm going to remember the picture, is the librarian. The librarian knows where all the stuff is, kind of keeping things where it's supposed to be, making sure that if it's out of place, it's going to put it where it needs to go. There are other things that do this as well. Hold on. I just need to shut my door. So there are other things that will do similar things. And that's where it gets a little confusing in this area, because like I said, we're going to dig into some deep dive into some things that it sounds like it's the same thing as something else. Know what that thing does. Know what it does in general. And then when you're reading the questions, and if it gives you, so in this case, if it said SQL is the librarian of databases, right? Look for the answers that are going to fit into that category and then which one fits most into that category. I know I'm not saying that the way that I want to say it. Maybe it'll come out, but you don't have to know every component of everything. You just kind of generalize. I would say you just generally need to know what it does in general, right? HTTP and HTTPS. I'm just going to break this down. Hold on one second. HTTP and HTTPS, Hypertext Transfer Protocol and Hypertext Transfer Protocol Secure, are protocols used for transmitting data over the internet. They define how messages are formatted and transmitted, and how servers and browsers should respond to various commands. I just noticed I have a bunch of spaces in there. HTTP is the foundation of the World Wide Web, and it's used to load web pages using hypertext links. So when you click on the link, HTTP is what is sending it. It's an application layer protocol designed to transfer information between the network device and run on top of other network protocol stack layers. So there's different layers in the internet, and the different names and domains, et cetera, are going to be built off of that. The S is an extension of HTTP. It uses encryption. So I have, for secure, that's what the S is, communications over computer networks, and is widely used on the internet. It protects data while it's in transit. These are going to be part of they're going to be the foundation to other pieces of some of the stuff that we're going to be going over. So a URI, and I'm sure you've heard URL, right? So URL is a website, but we're going to start with URI first, because the URI is here, and then URL and URN fall under the URI. Go for the last words in there. URI, Uniform Resource Identifier. It's identifying the resource on the other side. It's identification. It is a unique sequence of characters that identifies a logical or physical resource used by web technologies. URIs may identify anything, including real-world objects like people, places, concepts, or information resources such as web pages, books, the card catalog, etc. It's not just, URIs are not just specific to the internet. URIs are found other places in the world. So just as I said, the URI is kind of the category of what it is. And then URL is going to be location and then number. Okay. The URL, Uniform Resource Locator. Again, L, locator. Go right to the last word. Who cares about the uniform resource? It just means it's consistent for this thing and the location of it. Informally, it's called a web address. It is a reference to a web resource that specifies its location on a computer network and a mechanism for retrieving it. So you have my website there, right? It is not just this. This is considered the domain name. OnSceneFirst.com is the domain name, but it is also a uniform resource locator. If I was to add a backslash and then put studyENP, it's still a URL, okay? Because it's a location. If I click on that, it's going to bring me to a location. So anything that is a part of that initial OnSceneFirst.com /study ENP, that is part of the URL. The URL, if you think of it as I'm going somewhere, I'm going to pick a location, the URL locates the source and gets you into the neighborhood. But then with the little /, it helps you identify the actual house that you're going to. Okay. The uniform resource name. I said number before, I meant name. I apologize. Name, because it is a number. So the N, even though it's a name, it's a number. But it's specifically identifying something. It doesn't change. I'm going to use this term loosely to remember. In my little analogy here, we're going to go dark for a minute, but more often than not, we don't change our first name, right? So yes, some do, but for this analogy, we're going to use it as this. Is that generally speaking, if I'm born Tracy, I'm probably going to be Tracy when I pass on, barring any other changes or anything, right? By definition, the URN are globally unique. So while there might be other Tracy Ann Eldridges out there, were they actually Tracy Ann Weckeser before they were Tracy Ann Eldridge? No. So the uniform resource name is very specific to the one entity. Okay. URNs are globally unique, persistent identifiers assigned with defined namespaces, so they will be available for a long time, even after the identified resource ceases to exist or becomes unavailable. In other words, when we pass on, and you see the connection, the urn, get it? Urn. This is my connection to understanding that it is a name that is identified with a number that is specific to something that will allow it to cease after it will allow it to be located even after it ceases to exist or becomes unavailable. Urns cannot be used to locate an item directly, and they need not be resolvable. They are simply templates that another parser may use to find them. Now, that's the deep level, but on a just a general touch the surface basis, if I need to remember what the urn is, I'm going to remember that this is the unique number that's only identifiable to me, and that hopefully my stuff is the only one in that particular urn, right? And I say that because I listened to a podcast last week, and that doesn't always happen. There's some stuff with in Colorado, I think it was, that went on with. But let's take out the outliers and let's just go with the general understanding of the URN. Hopefully that makes sense. Where can I find the URN? As I mentioned, there are different places that you can find some of these things. The URL is going to be specific to the internet, and the URN, it could be libraries and publishing. So ISBN, ISSN. I don't know why, but that ISSN, International Standard Serial Number for periodicals, have URNs that include these numbers. I don't know why the ISSN is coming to, like, it keeps coming up in my brain. I don't remember if I saw it on the exam or somebody sent it to me, but it kept coming up. Digital object identifiers, standards and specifics, government and legal documents. So when you look at like the FCC's page, there's numbers like the document PS hyphen something. those are considered earns. It's going to be specific to that thing. You're not going to have that name on something else later. And then media and entertainment. All right. We are going to go let me see. Let me see. I'm on the fence. We're going to stop here for today. We're going to stop here for today. And then I'm going to record this next section and sent out. Given that we're at almost 20 past 4, it doesn't make sense for me to go into this section. I would be rushing. I would have to stop in the middle of something. And I just don't think that makes sense. I want to be able to have it as a group of this stuff. So with that, students, we have more to cover in this section, but I know that was a lot, and I just want to make sure that you are that I'm not rushing through it, because this is a lot. But do me a favor, message me with any questions. I know, Derek, you had mentioned the stuff that you had from someone else. If that is still available, please let me know, or if it's or if it can be shareable. I would appreciate that. Go ahead and like and follow me on social media. If you have any questions, you can hit that quick contact form QR code. And if you are in public safety and you want to join our On Scene First Safety Net group on Facebook, you can just type in On Scene First Safety Net and list the agency you work for, and I will be happy to let you in there. It's a safe place for us to chat mental health and wellness. And so with that, heroes, until next time, stay safe, stay strong, stay here. We need you.